So the first one you should have wrote down. I'll just quickly do the first one, then link up the second with you guys. So V equals KT, not UKT, KT squared. So dv dt, which is acceleration, is going to be K to the power 9 to the power plus 0.06 t. And we know that this acceleration, when t equals 20, we know acceleration is 1.3. So if you plug in k plus 0.06 multiplied by 20, it's going to give you 1.3. So that times 20 is 1.2. Take that off, k equals 0.1. Now that stays as it is. So now in part 2 tells you that after 20 seconds, car continues at a constant rate until it reaches a speed of 25. Okay. So what we got, find the total distance. Right, so basically what we've got some kind of quadratic going like from here to here, and then when it reaches acceleration 1.3, it just right, shouldn't use 1.3, sorry, that's an acceleration. That's going to be my, because I'm going to call this velocity. And then from here, my velocity is going constant. Just going to put this up here. Right, okay. So this is 0, and this is going to be 20 seconds, and then it will stop when this velocity hits 25. So at this point here, you can find out what the velocity is because we've got the velocity formula here. So at that point we can say the velocity when it's 20 is going to be 20, no, let's just do it here, 20 times 1.3, no wait, is it 0.1, k is 0.1, plus 0.03 times 20 squared. Put that in your calculator, you will get 20 squared times 0.03 plus will give me 14. Okay. Right. So we need to find those distances. Now, first of all, here you got the velocity is. You want the total distance, so it's an integral between 20 and 0, 0.1 t plus 0.03 t squared. Respect to t, you can just do that in your calculator. You're going to need a calculator, yeah. So integral 20, no, we took this in properly, 0.1 x plus 0.03 x squared. Okay. 0. What did you get for that? Anybody? Oh, I've got 100, yeah. So that's 100 meters. This travels from there. Now from here, we need to work out the area of this. Now, I've just drawn it, but you don't need to use that drawing because you can just use that. Because we need to find displacement. We know that initially the velocity is 14. The final velocity is going to be 25. And I know my acceleration remains constant, so it's 1.3. I don't know the time, I don't need to know it because I can just use this now, SUAVA. You should know the formula, U squared, V squared minus U squared equals 2AS. So I want to find that, so divided by 2A gives me S. Therefore, displacement is going to be 25 squared minus 14 squared all over 2 times 1.6 is going to be 2.6, 1.3, sorry. 25 squared minus 14 squared equals that divided by 2.6. Do you get 165?
Yeah.
Right. So the total distance travelled when it reaches that speed. Total distance is going to be 100. Gotta make it funny, otherwise you got to Kate, you'll be falling asleep, man. That'll be 265 meters. You know what I mean? So that was 100, and that was 165 meters. So the total is 265 meters.